this is the last argument session, and I can't believe we're already at the end. We are very excited and honored to have Dennis Pohl with us today. He's the director of the Flanders Architecture Institute, and he's going to be properly introduced by Shane Reiner Roth. But I think it's very important that we hear from Dennis. He's a very important researcher on questions of energy and politics. And he has a really wonderful book published from Sternberg Press called Building Carbon Europe, which goes over it examines different histories of coal, steel, and nuclear power, which are very important topics that I'm hoping to discuss with you today, especially as there's a very big discussion on how nuclear power should be reused from big architects like Norman Foster, and we can discuss these questions later. So thank you, Dennis, so much for coming, and we're very honored to have you, Shane. Oh, and sorry, one last thing. And for the final discussion, Dennis will be in discussion with Shane Reiner Roth and Mahum Erkin and Maria Eleni Komninu. Thank you.
It is my pleasure to introduce Dennis Pohl to the argument series. As a postdoctoral researcher at Delft University of Technology, Pohl was a member of the Design, Data, and Society group and worked as research coordinator at the New Open, an interdisciplinary project that imagines a society in which all data concerning the built environment is freely accessible. Pohl was recently appointed as director of the Flanders Architecture Institute, an Antwerp-based organization that raises public awareness on the importance of a well-designed living environment, one in which architecture is not merely an aesthetic or functional discipline, but a spatial practice for fostering social and environmental relations in the public sphere. His recently published book, on the other hand, outlines a history of architecture and political cooperation entirely unlike that for which he advocates. In Building Carbon Europe, Pohl reflects on a period in post-war Europe in which architecture was conceived as a governmental apparatus of geopolitical technology, a tool for shaping the future of the West following a devastating war, and a method for rationalizing colonial extraction and exploitation in a supposedly post-colonial era. In this way, Pohl adds a historical dimension to what structuralists like Claude Lévi-Strauss described in 1952 as the impending standardization of the world made possible by the West's pursuit of technical superiority. The examples throughout depict an architecture and infrastructure of carbonization, a built environment aiming for a world without friction, one that enables an ever-accelerating circulation of people, goods, services, and capital. And yet, in the present, we are all undergoing several frictions at once, between carbonization and the web of life, between an aging economy and an ageless ecology, and between humanity and the will of a select few. Though his focus is on post-war Europe, Pohl invites us to reflect on every corner of the earth, as the political agreements his book uncovers helped legitimize a global infrastructure that cannot handle the catastrophes it has set into motion. As New York City rapidly transitions into a subtropical climate, there is no better time to hear from our last speaker in the argument series. I invite you to please welcome Dennis Pohl.
It's a very big pleasure for me to present this lecture today here in this context, because part of it, what I'm going to present today, it's kind of laid out in a chapter in my book, Building Carbon Europe, really sparked out from a seminar here together with Reinhold Martin. I have a few colleagues here who are really remembering that seminar, which was about power in terms of politics and energy. So trying to understand the relation between an energy policies and the embedding of the energy policies and how these relates to broader political agendas. And in this way, how this chapter started is that I tried to understand the establishment of Euratom. Euratom is the European Atomic Energy Commission that was established in 1957, that was supposed to promote the peaceful use or the civil use of nuclear energy across Europe. And I try to look in the archives and understand why particularly Euratom had its main seat in Brussels and how the supposedly civilian use of nuclear energy had military consequences on other territories that are basically not in Europe. And in this way, part of what's going to be presented today is tracing back a broader nuclear history, or a history of nuclearity that goes back to the very origins of nuclear power, to the first findings of uranium, and the sort of cultural assumptions that are embedded at those very first moments of the discovery of uranium as a mineral by geologists and later mineralogists, that has implications that we witness still today in terms of environmental crisis, in terms of political crisis, in the way how they affect our current way of living. But I would like to kind of start to begin this lecture with a genealogy of nuclearity. Nuclearity is a term that was coined by the STS scholar Gabriele Hecht, that defines nuclearity, quote, as a technological phenomenon that emerges from political and cultural configurations of technical and scientific things, from social relations where knowledge is produced. For example, uranium mined in African countries like Niger, Gabon, Congo, or Namibia was crucial for the nuclear industry. Yet, paradoxically, these countries are not considered as nuclear states in Western classifications, even though their uranium fueled power plants and bombs in Europe and North America from the Second World War onwards. So in a way, some nuclearity is actually not an inherent quality to materials or technologies, but it's a historically and geographically situated designation. It shows how nuclear order is shaped not just by physics, but by politics, labor, empires, and techno-scientific infrastructures. And I would like to add on that also architecture plays an important role in making those resources accessible and divulgates them in what we call today our culture of modernity. So if we look back to the kind of very first findings of the Shinkolobwe mine, which was the first uranium mine where uranium was sourced in the Congo, we kind of have to go back to the very deep, dark colonial era in when the Congo Free State was literally a proprietary of the Belgian king at that moment, King Leopold II. Jules Cornet, who was a geologist standing on a second person here from the right, was taking part in an expedition in 1891 to 93 that actually was sourcing for several copper mines at that moment, and where uranium was actually seen as a byproduct of the copper production at that moment, and not even being recognized as radioactive at that time. So if you look at his kind of first map that he produced in of those mines, you see actually, if you overlay them with today's map, that between Kambobwe and Figurume is what you see there as one of the blue dots is the Shinkolobwe mine. Why this mine is so particularly important, even in the present day context, is because it's not just uranium and copper being mined there. It's cobalt, it's a lot of rare metals being mined there, which still affecting our, not only the ecological environments there, but also our present day realities. So I did a little overlay of maps from Google Earth that trace back the recent developments from 2017 to 2025 that coincides with our kind of vast use of electric vehicles, green energy, handheld technologies, and all sort of AI-driven computational power that bases its really fundings on those resources exploited in those territories. So while the Shinkolobwe mine, which is in the center, which is the historical uranium mine, has been sealed after the Second World War and fully closed apparently in 2004, according to reports, illicit mining was still going on, and other mines which you see in a kind of nearby territory has been still expanding dramatically around these areas. And if you look at the Shinkolobwe mine itself, if you zoom into that mine, basically you see boreholes or holes that show literally illicit mining activities. Those perforations in this surface are not made by huge machines. They are made by basically miners that were exposed to radioactive materials, exposed to labor conditions which we don't know anything about and are basically showing or a mirror of the way how we use technologies in the present day. So those sort of post-colonial era still affects a lot of territories, a lot of material chains, supply chains in our contemporary technological products that still are based on the exploitation of labor and the territory at place. And if you look back at the notebooks from Jules Cornet at that time, what you find are actually next to kind of observations of geological observations and also cultural observations of indigenous towns. You find also between the notes moments in which he describes basically a culture that for him is at that moment, or it is a racialized view on culture, on indigenous culture, and you can find it in this quote that I would like to read, which is on the top right there. Le commandant achète à une indigène un fin fil de cuivre rouge enroulé comme une corde de piano. Les indigènes prétendent que cela est fabriqué dans le pays. So he describes that the commandant actually gets a piece of copper wire, a thin copper wire from an indigenous person at that in that area which they are visiting, which is very close to the to Monkombobe, basically the Shinkolobe mine. And according to him, the indigenous pretends that it's fabricated in their country. So those geologists, they don't believe that actually technological development can happen outside of an industrialized territory. But it shows that there is still another form of production of cultural techniques that are also able to source those materials, to work around those materials. But this is a highly racialized view, of course, on the way how this culture is being seen. And in that moment, around the Kambobe mine, he also describes 3 materials that he finds around there: an oxyde noir, the cuivre, which are all with question marks. So this is like a copper oxide. The second is a limonite with a big question mark. And the third part is Kupferpecherz, which is a kind of a pitch blende that you could call it today. What he really discovers is actually in the stratigraphy is next to copper, a yellow stone that is actually uranium, and a patch blende that is also highly radioactive at that time. Oops, sorry. So if you look at those tracings of excursions that happened between 1970 and 1982, you see, between Tenke and Bukeya, the Momkombobe area, which are those 2 mines basically, which are the Shinkolobe mines at that moment. Those are excursions that keep on taking place in those 22 years of a whole Katanga territory around there. And more and more after those geological expeditions have been kind of scheduled, there are more and more maps produced that map the Katanga territory as a resource territory. And of course, it becomes also at that moment a broader international concern. If you look here, what is written there is a sphère des intérêts portugais. So it's a Portuguese interest sphere. Sphère des intérêts anglais, an English interest sphere of geology. And here you see Sphère des intérêts allemands. So all those exploitations, you barely find actually anything about those when you read colonial histories around there, but they are present in those maps and in those in those descriptions of these territories. And what happens is that in 1915, because of this broader international interest in these territories, Robert Rich Sharp, which is a geologist trained under the mineralogist Samuel Hansen, takes part in by a company by an expedition which was commissioned by the company Tanganyika Concessions, which was linked to Cecil Rhodes at that time, prospected the area, also prompted by Leopold II, to establish the Comité Spécial du Katanga, which is actually an association that was asserting Belgian mining rights on that territory. So Robert Charles worked with the Tanganyika Concessions and later with the Union Minière Haute Katanga, which was formed in 1906 by the Belgian and British companies. In 1913, Sharp discovered radioactive minerals near Lubumbashi, which was confirmed by the Belgian geologist Henry Butgenbach, and in 1915 found a uranium-rich pitch blende at the Shikolove mine, which is at the Kazolo Hill that I just showed. So the mining for radium actually began in 1921, where the first ore was processed afterwards in Antwerp, and the mine's production eventually outcompeted the Colorado mines that were closed in 1937. So this is the map by Sharp, or produced by Sharp, if you zoom in, where he passes by the Katanga territory where the Shinkolobe mine is located. What Sharp also produced next to descriptions are those kind of sections through the earth. So the section, which is actually, you could say, it has an architectural origin as a sociocultural technique to understand the construction details of how a building is built, serves here as a technology to basically slice a section through the earth. It serves as a way of seeing the earth as a resource that can be mapped, classified, extracted, sourced, and exploited. So in a way, those drawings basically are the very beginning to understand of where resources under the earth are located, and they serve as a media basically for later exploitation that happens until the present day. It's in 1908 where Shinkolobe appears. 1915, where Shinkolobe appears for the first time on the map. That was produced by the Comité Spécial de Katanga. And in 1921, the Belgian mineralogist Alfred Schoep, who was working for the Union Minière Haute Katanga, described basically the basic conditions of uranium. Again, next to a map that was published in his work, he basically looked at the first specimens that were transported at that time to Belgium. One side note I forgot to mention is that in 1908, the Union Minière Haute Katanga was funded, and the Congo Free State became the Belgian Congo. It wasn't anymore like the territory of the private property of Leopold II, but transformed into what was called the Belgian Congo. Next to the other descriptions, Alfred Schoep was also involved in basically the first description of the uranate material, which was a small amount of radium as a radioactive decay of the uranium product, which Marie Curie used as a pitch blende in her first experiments with radium. So that's where also the name Curite for another mineral comes from, that Alfred Schoep described in 1921, which was named after the physicist and Nobel laureate Pierre Curie at that moment. Another mineral was called Sharpite, which is named after the geologist Robert Rich Sharp, which was also discovered. All those minerals are discovered basically at the Shinkolobe mine. Another mineral also described later on by Goethe and Pohl was called Sengherit. Sengherit was first discovered also at the LOEWE mine 20 kilometers north from Lubumbashi in the Katanga province of the Democratic Republic of Congo in 1949. And the mineral was named after someone named Edgar Sengher. Edgar Sengher was a former director of the Union Minière Haute Katanga, and he is credited with giving the American government access to the uranium necessary for the Manhattan Project, much of which was stored back then in Staten Island in a warehouse. Due to his foresight to a stockpile, the ore was to prevent it from falling into possibly hands of Nazi Germany at that moment. However, that name still persists in that mineral, and for his actions, he became awarded with as a first non-American civilian with a Medal for Merit by the United States government. So those histories that are basically linked to a broader to an extreme violence of the construction of the atomic bomb basically are still traced and uncritically traced in the way how those materials are named. Radium was, of course, from the 1930s onwards the biggest export product for Belgium at that moment. Here Edgar Sengher was showing the Belgian King Baudouin, a rock of uranium ore, which was exposed at the back then at the African Museum. And in 1933, a much more thorough mapping of the Shinkolobwe mine began with Thoreau, Trieux, and Terdonck, who basically sliced also all the material specimens in those little kind of squared slices, round slices, in order to describe their chemical, basically their chemical consistency. But of course, this is just another scale of slicing or another way of sectioning, not only the earth as a large scale format in terms of slicing a mountain, but slicing the stones itself becomes an act of describing and understanding the mineral constellations of those specimens, which contains also again a process that has caused or that's for sure causing radioactive dust produced by cutting them into pieces. So it's not clear. It's not described in any of those documents how and by whom these slices have been cut, but clearly radioactivity is involved in the process itself, and possible exposure to uranium is here at stake. So again, the labor conditions and the exposure to uranium is a given condition, but is not taken any considerations in terms of the effects that it has on the health properties, not only of the mining workers, but then also of the other executive workers that were using basically techniques to slice those materials apart. And what you see here is the first section and access points to the Shinkolobwe mine being mapped out by Thoreau. What followed after this period in the 1930s was literally a radioactive boom, you could say. Radioactive products were part, and radium was part of all kind of cosmetic products. It became used as a color pigment, and it was basically distributed in all kinds of everyday products, which people could acquire in normal shops. So again, not knowing the full capacities and the properties of radium led actually to a part in which those products were distributed in all kind of cosmetic products, activating creams, even a radium water that was back then sold back then to improve the health, glowing necklaces, because of course this material would still glow in the dark. It was used by a company, it was based in New York, I figured out, which was called Undark at that moment, providing and producing a radium-based luminous color that was applied on several products. There is a story linked to it, or a court case linked to it, which was coined as the Radium Girls, women that were exposed in the production of those products filed a court case actually around that company. But the Shinkolobwe mine continued to be exploited by in Katanga by the Union Minière, and by the 1930s, the Katanga region was actually a largely infrastructuralized open pit, basically, where the Union Minière Katanga had constructed a train network or a railway network that was as big as Paris at that moment for a private company. You could imagine the amount of power being actually centralized in that region. The Africa Museum that is located in Brussels today in Tervuren has still parts of the mineral collections that are there. Radioactive minerals are not exposed anymore as they were before, but there are still more than 300 specimens that are not classified or don't fall under a regular classification system. It's like an amount of minerals, gems that are basically still, in one way or the other, a bit uncritically exposed in that museum. That museum was also the source of the archives that you've seen there at the very beginning. The Union Minière continues to produce and to extract minerals in Central Africa under the name of Umicore, and constructed back then huge infrastructural projects such as this one, which is a campsite for mining workers at that moment in Lubumbashi, which was separated with a so-called cordon sanitaire, with a green sanitary belt from the European city. If you lay over a map of today, that's what you see on the left side are basically the quartier Gécomin. Gécomin is basically also a subsidiary company of Umicore now. There's a Gécomin graveyard basically on top of it. And on the other side, the so-called European city, with the mine basically separating in the dark pit that you see there, those two parts of the city. Uranium became, of course, a crucial material during the Second World War, and this was also, and basically the Belgian Congo, central to that territory, was also already mentioned in the letter that that Albert Einstein wrote to President Eisenhower at that moment, where he basically mentions that in the course of the last 4 months, and I particularly read out that letter because it shows basically the fear that was embedded and the potential that he also saw in the material of uranium. In the course of the last 4 months, it has been probable through the work of Julio in France, as well as for me and César in America, that it may be possible to set up a nuclear chain reaction in a large mass of uranium, by which a vast amount of power and large quantities of now radium-like elements would be generated. Now it appears almost certain that this could be achieved in the immediate future. This new phenomenon would also lead to the construction of bombs, and it is conceivable, though much less certain, that extremely powerful bombs of a new type may thus be constructed. A single bomb of this type carried by boat or exploded in a port might very well destroy the whole port together with some of the surrounding territories. However, such bombs might be well proved to be too heavy for transportation by air. What he says afterwards on the right top of the letter, that there is some good ore in Canada and the former Czechoslovakia, while the most important source of uranium is the Belgian Congo. So in a letter from 1939, Einstein himself basically points out the strategic geographical importance of the Belgian Congo. And it is actually based on that letter, Oppenheimer basically starts his mission, and you know that story, of course, basically to to source and contact Edgar Segnier, who provides the uranium for the Manhattan Project. This uranium is basically transported first from the Belgian Congo to Belgium itself, where it gets raffinated in Olen and Hoboken. What you see up north is Antwerp. So it's a port city which basically allows the radioactive pitchblende basically immediately to leave the country towards the United States at that moment. And at that this company, that is the Société Générale Métallurgique de Hoboken, which is basically the Union Minière Haute-Katanga at that time, still exists today. Today it's called Umicore. It's still one of the biggest mining companies of ores in Central Africa. Umicore also controls access to the Union Minière archives at the Belgian State Archives. So a few of those documents that I tried to consult are in a so-called liste rouge, a red list that is blocked from access for about 100 years. So I didn't have time to wait until 2052 to finish my PhD. But of course, those documents are still of strategic relevance, and they show basically the implementation in the conflict of an independence of Congo and the involvement of the Belgian state in the strategic aims about this. What you find also in those archives are basically drawings of vessels where basic uranium material, the U-238, is being transported from Hoboken to the United States, or another form of architecture that serves basically the transport of those radioactive materials from the mines to their processed and raffinated source materials in order to construct basically the Manhattan Project. This drum itself has been, or this drawing itself has been provided by the so-called National Lead Company of Ohio. If you look up the National Lead Company of Ohio, it was basically the center that allowed for distribution of mineral salt, of uranium salts and refined elements and uranium metals, basically in all over the United States. So during the war, the Manhattan Project, Fed Materials, probably had employed different companies in widely separated cities to produce the feed materials for the production processes themselves. In the early post-war period, the Mallinckrodt Chemical Works in St. Louis turned uranium ore into uranium dioxide, UO2, known as brown oxide, while the Harsher Company in Cleveland turned its oxide into uranium terafluoride, which was a so-called green salt, basically, you see on top of this drawing. Uranium hexaoxide and the uranium carbide are basically the electrometallic division, turned green salt into uranium metal, and the AAC operated storage facilities in Cleveland and the Middlesex sampling plant in New Jersey for that. And of course, what happens with the green salts, basically after it is shipped to Portsmouth, that is also then distributed to Oak Ridge as well. That's one of the factories in the Hanford nuclear complex in Washington State, where part of the Manhattan Project was located in order to produce those aspects. What was also at that moment produced were this type of calculators to understand the dimensions of nuclear explosions. So what was basically designed by the Lovelace corporations, which used data from the book The Effects of Nuclear Weapons in 1962, made actually this little plastic computer with an envelope of instructions to understand the diameter and the radius of bomb craters. Interestingly enough, it was Ludwig Hilbersheimer that used precisely that book and that calculator for his in his book The Nature of Cities, to construct an amount of a new city map basically throughout the US that would be indestructible. And other architects have been already involved in the testing basically of the Manhattan Project. to understand the total bomb capacities of nuclear bombs. In consultation with German Jewish immigrants Erich Mendelssohn and Konrad Wachsmann, as well as the Czech architect Antonin Raimond, in 1943, in the Dugway ground in Utah, there was a construction of a typical German and Japanese village erected to test basically fire bombs of Allied air raids. The so-called German-Japanese village was basically based its planning and its research on the urban structure as well as the construction and the materiality of typical buildings in their territory in Germany and in Japan, corresponding also to the furniture. So in these documents that are published, basically you find next to the very detailed section of those constructions also descriptions how the classic habits would be allocated in those buildings. So during the preparation of the atomic bombings, the US military built those mock villages to replicate the typical German and Japanese home, and allowing scientists to test and refine the incendiary bomb techniques for a maximum destructive effect. The Japanese village in particular was constructed with a careful attention to authentic materials and designed to ensure that the bombing tactics developed would effectively destroy Japanese urban areas. So you see this meticulous wood frame constructions, which also tatami mat floors, sliding shoei screens, as well as the authentic interior furnishing was used to mirror the domestic life in Japan. This level of detail ensured that these bombing techniques could be optimized for maximum destruction of densely built residential areas. This reveals also that how mock villages themselves functions as architectural experiments in weaponizing intimate everyday spaces, illustrating the deliberate targeting of civilian life embedded in this wartime strategy. In the 1970s, Claude Parent had this particular mission to promote a peaceful use of nuclear energy, which was, of course, due to the effects of the atomic bombs, seen as an absolutely problematic technology. And in his designs, he basically tried to implement and foster a sort of a friendly use of nuclear power, in which those almost sculpture-like buildings basically were embedded in his broader landscape design. So again, architects played a crucial role in designing not only the destructive aspects of atomic bombs, but also their so-called peaceful use themselves. Again, the stories of the territories where the materials is sourced, the ecological problems that those are produced within are not considered in any of those experiments. And this becomes also visible in a World Expo that I analyzed also in the chapter that you read in preparation for that course, in Building Carbon Europe, namely how nuclearity was displayed and how this sort of a double use and this conflict was basically staged in the way how nuclearity was displayed at the Expo 58 at that moment. So I looked at Euratom and basically the treaty that was set up in 1957 for the civilian use of nuclear power. That was based on a three-party agreement in 1954 between the US, Belgium, and Great Britain at that moment, which is already problematic itself, because the document basically is a three-party agreement over the resources from another country. And in that establishment of the three-party agreement in 1954, there are big concerns of how those three states should agree, although the mineral is being sourced by a private company, by the Union Minière Haute-Katanga. At that moment, the Belgian state in those documents and in the letters basically secured that there is no problem, because it's almost a kind of a state-based company. And for Euratom, basically promoting the civil use of nuclear power, they launched also several campaigns and several propaganda campaigns, basically to distribute that. Among which you can find this Euratom movie online, or this little film snippet online, according to which, quote, "The proof of the atom's domestication is the steak grilled with nuclear energy," and nuclear generated energy, electricity. However, this peaceful use, of course, also implies the underlying colonial networks, because it requires the geopolitical management of uranium resources. This geopolitical management has been consciously hidden from the public perception. And even if the so-called World's Fair of the atomic era had this humanistic agenda behind promoting the so-called peaceful use of nuclear energy, it had us also as a subtitle, "Evaluating the World for a More Human World," unquote. In the course of this presentation, I would also show how this humanistic agenda, of course, needs to be questioned by looking more closely at the phenomena with the power relations that the so-called peaceful use of nuclear energy brings about. And second, we might ask to whom this humanistic agenda basically serves and whom it excludes. The Expo 58 has received relatively little attention from architecture historians in comparing the other two significant world fairs that Siegfried Gideon back then also described always as a trial ground for new methods, and by others as so-called laboratories for modern architecture. So, but if you look at Expo 58 as a laboratory for nuclear power in modern architecture, there is a very dark history basically underlaying this laboratory. So what is not proposed here is basically that Gideon's argument can be reversed in itself, since he argued that in the 20th century, the World's Fair would have lost their sort of creative force by focusing on consumer interests instead of the relation between forces of production and architecture. If we follow the path of the atoms, then we see that the consumer products presented at the Expo led basically to the questions of production and the role of architecture, which privileges certain agents and their humanistic agenda through the stabilization of a colonial order. And therefore, architecture is basically regarded as a medium and as a message for this new humanistic agenda, and giving this new humanism a potentially a new architectural form. This was then also literally taken by André Waterkain, who was the engineer of the atomium, who used this crystalline form of so-called, I think, 100 or 200 times enlarged iron atom, basically to create a sort of atomic stability of relations, and this atomium became a symbolic representation of the Expo, propagating the so-called peaceful use of nuclear power. What the Expo Commission promoted in 1954, actually even before, is together with the director of the Union Minière Haute-Katanga, they launched a discussion that wouldn't it be the best way to promote the peaceful use of nuclear energy by placing a nuclear power reactor on the exhibition ground themselves. So in 1956, there were the first drawings of that nuclear power plant that's supposed to be located on the Expo ground, where people could literally visit a fully working reactor. Henri Robillard secured back then, with discussions that he had with Louis Strauss, the back then president of the US Atomic Energy Commission, that this would be basically supporting Eisenhower's idea of a new peaceful use of nuclear energy. And Westinghouse agreed to basically supply the first water-cooled industrial reactor to Belgium, while the Union Minière Haute-Katanga would basically link this to a big uranium deal, supplying the necessary radioactive material for that endeavor. These are also the perspective drawings from that. If any one of you is familiar with Brussels, this is the canal that runs through the city. The city center is sort of eastwards towards that area. What you see on the other side is the expo ground, located on a little hill where the reactor should be located. What is here on the left side, not drawn in this territory, is basically the royal garden of the king. And literally the only opposing voice was back then the king's palace, not wanting to have a nuclear reactor in their backyard, you could say. At the end of the day, the nuclear reactor was built in Pohl, situated 50 kilometers on another side, western from Brussels. Still, what was presented at the Expo 58 was also the Congo, mainly as in the pavilion of mining, basically staged at its best with abstract maps, and the political conditions of mining were gloriously overlooked. The Belgian state company Union Minière here was on the right side of a display, present with a block of uranium ore that was not only the supplier for the Manhattan Project, but also regulated the cooperation with the European Atomic Energy Agency, the uranium supplies to Europe after the Second World War. The uranium monopoly was the parent company of today's Umicore that I also described, which still mines cobalt and other rare earth minerals in the Congo and holds also the archival rights. Not being shown, or what was shown basically or exhibited back then as a primitive indigenous way of life, was basically the Congo section on the Expo 58. On the backside, with the designers of those pavilions, clay materials, straw huts were chosen instead of modern materials that were sort of setting in contrast a so-called exotic indigenous life, in a sharp contrast with the so-called atomic modernity. So here you see another of those displays, which recalls, of course, the way how urbanism has been produced and constructed in the Belgian Congo, literally separating the so-called ville indigène from the European city. Something similar has been recreated on the Expo 58. A few years after the Expo 58, Patrice Lumumba was elected as the president of the Congolese state, and signed in June 1960 with Gaston Eyskens basically the agreement for the independence of the Belgian Congo. 11 days after the Democratic Republic of Congo gained their independence, the Katanga province that I was showing you before on these maps, where the Shinkolove mine was located, seceded from the country. So there was a country that became independent from the independence. The private mining companies working with Western governments likely planned the succession in order to secure the uranium production, no matter who stepped into power. After the secession, Lumumba reached out to the Soviet government and other states in order to help, which only heightened the US concerns. And after less than 6 months where Patrice Lumumba was empowered, he was assassinated in a mission that was partially authorized by President Eisenhower, partially also staged and also made possible by the Belgian state. It is still until present day unclear who actually killed Lumumba. The family has just recently again reopened the court case against one of the ambassadors who was involved, who's still alive, in that court case. In that government of the Belgian Congo at that moment, and it's still not clear who had actually, or who can be said guilty. There was no sentence spoken out from any of those processes that were going on until so far. So it is still a very a present case, and it's still the link between present-day companies, the Belgian government, are so evident that any investigations are basically blocked through authorities. In 2011, there was a parliamentary inquisition started by the Belgian Parliament, which came to the conclusion that they could not sentence anybody directly from that process. But still, it is evidently a war crime being produced. And a nuclear modernity that also sparked through that period. I don't know. I think we're running. Are we running short on time? Yeah. Okay. Still have like around 10 minutes here. What sparked, of course, in the 1960s and 70s was also a nuclear modernity that was embedded and produced together with architecture to facilitate and promote the consumption, basically, of so-called nuclear spaces. The assumption of infinite energy, which was at the core of nuclear power, became most embedded in designs that the designers themselves have ignored in the role of the origins of those of those resources. For example, in The House of the Future by Elson and Peter Smithson, even though the peaceful use of nuclear energy has been presented in their own descriptions, for instance, they claim that the conservation of food in the house was guaranteed because all the food was, quote, bombarded with so-called gamma rays, an atomic byproduct to kill bacteria, unquote. In particular, they go on, as the electric power drawn from the nearest atomic power station that is used for the heating, lighting, air conditioning, and water heating, cooking, and the house laundry and refrigeration. Heated floors provide whatever warmth is required in any area of the house, and air conditioning sees to the mechanical extraction of all smells and ensures that the dust infiltration is practically non-existent, unquote. The statements clearly emphasize that the addition of the non-existence of dust infiltration, a subtle awareness of the energy consumption of heated floors without a basement, is also practically non-existent, affirming that the assumption that energy from nuclear power is available at an infinite level. In the 1964 Expo in Osaka, also another house was shown, basically, that had a sort of an underground bunker at its basis. So also there, so-called in war times of nuclear explosions, those architecture facilities, basically here promoted also in the Life and published in the Life magazine, was basically constructing beautiful romantic gardens with views over Manhattan on a bunker territory in this household. And on this device on the left side, you could literally check the radiation that's going on outside the house. In several architecture magazines, this new sort of bunker architecture was promoted as a way to securing our futures. And this imagination, or this sort of imaginary aspect that went in hand, is also something that is reappearing in popular culture at that moment. If you look at the early comics of that time, you sort of find like kind of two dichotomic areas. It's either someone gaining superpowers through nuclear energy, or a complete destruction being basically produced by that energy itself. And again, it's the exposure of nuclear energy that is then put into this dichotomic way of imagining radioactivity. So this kind of friend-enemy dichotomy is basically something that runs through the production of or the presence of nuclear exposure, nuclear energy at that moment. It is, I think, only one comic that basically rereads this through another perspective. Is, of course, a Black Panther, which imagines a world where a population, an African population, had access and fully control over their own all resources in this territory called Wakanda at that moment. So let me conclude by bringing this together, these core ideas of these presentations, which are maybe some loose ends at all aspects. That uranium from Shinkolobwe was an essential for the Manhattan Project and our present day form of nuclear modernity. Yet the Congolese mines and the workers were erased from the nuclear histories of the 20th century. Both when it comes to design and architecture, those histories are completely ignored and unpresent, even when we talk today about Norman Foster's idea of the so-called small microreactors that could be placed in cities and everywhere else to allow our sort of independence of oil resources. The story of uranium in Central Africa reveals that not just by the material extraction of a radioactive element, but the production of what Gabriel Hecht termed nuclearity, a contested, historically situated status that is not inherent to uranium itself, but rather distributed to technologies, labor regimes, racial hierarchies, geopolitical power structures, and architecture in forms of design. Then the way of nuclear energy becomes embedded not only in our global infrastructures, but also in the very social and political forms of modernity. It is what also Mimi Scheller links in her also text that you prepared, hopefully, for this seminar, as a sort of the origin of carbon that to the racialized mobility of modern societies and paramilitary interventions, so that we can trace the path of uranium from the mines to the atomic bombs as a racialized and imperial form of world making. In this light, nuclearity is not just about the technology or danger. It is about who gets to define what is nuclear and whose exposures are recognized. The history of the Shinkolobwe mine, hidden in the Congo's forest, reveals how African resources powered global nuclear ambitions, while African miners and landscapes remained largely excluded from nuclear citizenship. To conclude, tracing the uranium's journey from the mineralogical curiosity to the geopolitical fulcrum, and it's entangled with its post-colonial statehood, scientific visibility, and global asymmetries, shows us how the legacy of nuclearity and carbon form are not behind us. They persist invisibly, structuring both our energy futures and our planetary vulnerabilities today. Thank you very much.